Okay, so the first slide for 2.2 today, this is just kind of a review. So here we have this vertex form of our quadratic. Remember the equation is f of x is equal to a x minus h squared plus k. And then just a little review, so the vertex is going to be at hk, and then the h is always opposite, so if it's negative, like in the equation, you know that it really goes over to the right and it's at the positive. And then the k is the up or down, so that's going to be, if it's positive, it really goes up, if it's negative, it goes down. So the vertex, the h is always just opposite. Our line of symmetry, so remember what that is. So if I have any quadratic, wherever it's drawn, I always have some line right down the middle that's going to be my axis of symmetry, and this line is where you can take one side and fold it over, and it's going to like land right on top of the other side. Okay, and the way you write the equation for that line is x equals whatever the h value is. Okay, because it's, if our vertex is right here, the vertex coordinate is hk, the h is the x part, so your line of symmetry is going to be a vertical line, so it'd be x equals and then h. And then our min and max value, so that has to do with like the height. So if our quadratic looks like this, if it's opening up, obviously you're going to have a minimum. This is your lowest point on your graph. And so the way you would write that would be y equals k. If your graph is a quadratic going this way, so it's opening down and your vertex is up on the top, it would be a maximum, but you would still say y equals k. Okay? So yeah, so minimum if it's opening up, maximum if it's opening down. Can you guys see that? I know there's kind of a glare, which my room isn't great, but can you guys see those graphs up there? Are you doing okay? Okay. All right, so continuing on. So then standard form, we talked about this last time. So this is when we have ax squared plus bx plus c. Well, to go from standard to vertex form, we can actually find our vertex from our standard form. And the way that we do that, because remember our vertex is at h and k. So the way that we do that is we use, to find the x coordinate of our vertex, to find our h, if we just use negative b over 2a and solve that, that's going to give us what our vertex coordinate is. So like your b is always your value that's attached to just your x, and then your a is your value attached to your x squared. So if you do negative b over 2a, solve that out for a number, and that number is going to be the x coordinate of your vertex. It's going to be your h. Then to get your y coordinate of your vertex, if you just put what you just solved, your h, back into your original equation, it's going to go ahead and find your k for you. And then you would have your h and your k, and you would have your vertex. So we can go from standard to vertex form. So if I do this example, I have f of x is equal to x squared minus 6x plus 10. So looking at this, I can go ahead and identify what my a, b, and c are. My a is just going to be my number attached to my x squared, so it would just be 1. So I would have my a is 1, my b is my number attached to my x, so I'd have negative 6, and then my c is going to be just my constant, which is 10. And I don't really need the c right now, I just need the a and the b, but it's okay, we know what all of them are. So then to find my h, so to find my vertex, if I do h is equal to negative b over 2a. So then I'm just going to go ahead and plug in these numbers, the b and the a. So I'd have negative 6, which I know that that's going to make a positive 6, over 2 times my a value, which is 1. So I'd have 6 over 2, which is going to be 3. So my x coordinate of my vertex is going to be at 3. Now to find the y coordinate of that, I can take this number I just found and plug it in for the x's in my original equation, and that's going to give me the y coordinate there, so then I would have my vertex. So if I do that, if I plug those in, I have f of x is equal to, I'm just gonna put the 3 in for my x's, so I'd have 3 squared minus 6 times 3 plus 10. So then 3 squared gives me 9, minus 6 times 3 is gonna give me 18, plus 10. So then I have like positive 19 minus 18, so I'm gonna end up with 1. Okay, so my vertex is gonna be at 3, 1. So here's my vertex. The x coordinate was 3 and the y coordinate was 1. So anytime you see an equation in the standard form and it asks you to find your vertex, you can use this handy little equation, the negative b over 2a. That's gonna give you your x coordinate of your vertex. Then just plug it into your equation and you're gonna get your y coordinate, okay? Any questions so far? Is good?
Question.
Yeah.
So your B, so I'm confused. What is your B and what's your A?
The a is always going to be the number attached to the x squared, and the b is always the number attached to the x. So in our example, we didn't have a number attached to x squared, so it would just be 1. So like anytime you have, like don't have 1, it's 1. And then the b was the negative 6. So yep, so every time a is what's with x squared, b is what's with x, and then c is just the constant. Okay? Any other questions, or so far so good? All right, let's go ahead, let's go on to the next slide. So if you change that on your PowerPoint at home. This one, it says we're gonna graph a quadratic function in standard form. So my equation is x squared minus 4x plus 8. Well, looking at that, I have no idea how to graph that. So I need to find my vertex, so I would know where to plot my vertex, and then find a couple of points and use my symmetry to graph it. So first thing, I just have like some steps for like helpful hints for how to graph this. It says identify my values of a, b, and c. So my equation, I have f of x is equal to x squared minus 4x plus 8. So then my a, my b, and my c, my a is my number attached to my x squared. So my a is just going to be 1. My b is my number attached to my x, so I'd have negative 4. And then my c is just my constant, so that would be 8. So I just look at my equation and look at the numbers, not the x's. So the first number is your a, the second number is your b, the last one is your c. Okay, so then it says we need to find our vertex. So since we know that, we can go ahead and find our vertex. So to do that, if I use my equation, h is equal to negative b over 2a. This is going to give me my x coordinate of my vertex. So I can go ahead and plug in. So I would have negative b, so I'm going to have negative 4, which is going to be positive 4. So I'd have 4 over 2 times my a value of 1. So 4 over 2 times 1, which would give me 4 over 2, which is going to give me 2. Okay, so I end up finding out that my x coordinate of my vertex is 2. So then to get my y coordinate, I can go ahead and take that number and plug it back into my original equation, and that's going to give me my y coordinate. So if I do that, I started with my original equation, so I have f of x is equal to x squared, but I'm going to plug in my 2 for my x. So I'd have 2 squared minus 4 times 2 plus 8. So then I'm just going to solve this out. So 2 squared is 4, minus 4 times 2 would give me 8, and then I have the plus 8. Well, the negative 8 and the positive 8 are going to cancel each other, so I'm left with just 4. So I find out that my vertex is going to be at 2, 4. Okay? So then, once I have that vertex, it says find my y-intercept. Okay, because I'm just trying to find a couple of points to plot so that I can make an accurate quadratic. So there's a note, it says the y-intercept is always going to be my c. So whatever number, just like if you think about like y equals mx plus b, like a linear equation, that last number was always like your y-intercept in linear. Well, if you're in standard form, then the last number is always your y-intercept. Okay, so the c value is always going to be your y-intercept. So I know that it's going to be at 8. And another way I could have solved that if I wanted to solve it out, because I know my y-intercept, it's going to be when my x is 0. So if I were to plug in 0 into my equation, because I know like to find a y-intercept, that's when x is 0. So I would have 0 squared minus 4 times 0 plus 8. Well, all of that would be 0 except for the 8. So I know that my y-intercept is going to be just at 8. Okay, so it's always going to be just at your C point. Okay, so let's go ahead, let's start making a graph. Okay, so I have a vertex at 2, 4. And I have a y-intercept at 8. Okay, so I plotted my y-intercept up here at 8, and I plotted my vertex at 2, 4. Well, based off of the symmetry, I know that since I went over 2 in this direction and up 4, because here I am at 0, 8, I can also go 2 in the opposite direction and go up 4 from my vertex as well, because I'm going to have, here's my axis of symmetry right down the middle at x equals 2. So I know I also have a point at 4, 8, just based off of that symmetry right there. Okay, and then we also know, because it's just 1x squared, I don't have a number in front of my x squared. So the little trick that we learned in the first section, where you can go from your vertex and you can kind of, instead of doing slope, we always start from our vertex, and if we go over 1, well, 1 squared is 1, so I would go up 1. So I'm going to have a point at 3, 5. So, and then for my vertex, I can go over 2. Well, 2 squared is 4, so I would go up 4, which gives me that point that I already plotted. Okay? And then if I went over 3 from my vertex, 3 squared is 9, so I would go up 9 from my vertex. And I could go over 4. 4 squared would be 16, so then I would go up 16. So instead of using like rise over run, like that kind of slope, we always count from our vertex, and however many you go over, you square that number, and that's how many you go up. Okay, so when you go over 1, 1 squared is 1, so you go up 1. When you go over 2, square the number you went over, so go over 2, square that, you go up 4. Okay? And the same thing on both sides. So because I have this point here at 3, 5, using my symmetry, I also know I would have a point at 1, 5. Okay, because I can go over 1 in this direction, and then 1 squared is 1, so I would go up 1. Okay, so then I'd be able to just kind of sketch in my quadratic. Put some arrows on the end because it can keep going to infinity. Okay, so there would be my graph of that equation of the x squared minus 4x plus 8. Okay, so that's how you're going to plot them. So if you're asked to graph something and it gives you a standard form, you first need to find your vertex, because your vertex is like your main point. Like once you know where that is, you can figure everything else out. So if you see something in standard form, first find your vertex, then it's an easy point to plot your y-intercept because it's always just the c value. Then plot a couple other points to make sure it looks like an accurate graph, and then just go ahead and sketch in your line. Okay? Questions on that? Any concerns about being able to graph this? You guys can really have questions, like don't be scared. Nope? Okay, well then we'll just keep going. All right, so if you go ahead and change slides, now we have kind of like a word problem-ish. So this one, it says, the graph of the function, and it gives us the equation, negative 10x squared plus 700x minus 6,000, shows the profits a company earns for selling headphones at different prices. So it says, what's the maximum profit the company expects to earn? Well, if I think, I know that my max and my min, it just talks about my y value. So my highest y value is going to be my maximum. Okay, so if I look at that graph, to me it looks like it's, I mean, a little over 6,000, right? Doesn't it look like it's like up a little over 6,000? But to find out exactly what that is since we're given the equation, we could go ahead and just solve it for our vertex, because I know my vertex, once I find that point, the y value of my vertex is going to be my maximum. Okay, so if I see something like this and it asks you for your max or your min, you know you're using your vertex, but we only want the y coordinate. So let's go ahead, let's go from our equation to our vertex, and then let's look at the y coordinate of it, okay? Okay, so my equation, I have f of x is equal to negative 10x squared plus 700x minus 6,000. So my a, my b, and my c, I know that my a value is going to be what's attached to my x squared. So my a is negative 10. My b is what's attached to my x, so it's going to be 700. And then my c is my constant, so it's going to be negative 6,000. So if I go ahead and find my vertex, so to find my x coordinate of my vertex, I can use h is equal to negative b over 2a. So now I'm just going to go ahead and plug in what I have. So I'd have negative b, so negative 700 divided by 2 times my a value, which is negative 10. So I know that I'm going to have negative 700 over negative 20, which the negative and the negative, those are going to go ahead and cancel each other out. And then the 700 over the 20, I know it's going to be like, the zeros can cancel each other, so I have like 70 over 2. So I'm going to end up with just positive 35. Okay, so my x coordinate for that is going to just be positive 35. Everyone okay with how I got there? Okay, so now once I have the x coordinate, all I have to do is plug that 35 back in for my x's in my equation so that we can find the y coordinate. Okay, so if I do that, I'm going to go ahead and plug it in. So I have negative 10 and then x squared, but I'm going to plug that 35 in for my x. So 35 squared plus 700 times 35 minus 6,000. So now the way I need to do this, remember you have to follow order of operations to get the right number. So you want to do exponents first. So 35 squared is going to give me 1,225. So I'd have negative 10 times 1,225. And then 700 times 35 is going to give me 24,500. And then I still have just this minus 6,000. Okay, so all I did was I squared my 35, got 1,225, and then 700 times 35 was 24,500. Okay, now I can take my negative 10 times this 1,225, and when I do that, I'm going to have negative 12,250 plus 24,500 minus 6,000. So now if I were just to type all of those into my calculator or into your phone, because you guys are at home, we would have 6,250 would be the answer for that. Okay, so all I did was calculate that. So then my vertex, so my x coordinate of my vertex was 35, and my y coordinate of my vertex is 6,250. So my vertex, 35, 6,250. So then I know that my max, because that just deals with my y of my vertex, so this is gonna be my max. So to answer the question, it says, what's the maximum profit the company expects to earn? Well, we said looking at the graph, it looks like it was just a little bit over 6,000. Well, to find out the exact number, it's the 6,250. Okay, so that's the maximum profit that that company is gonna earn, is $6,250. Okay? All right, are we okay, or else I just have one last concept, one more slide. Okay, we'll go ahead and go to the last slide then. All right, so this is kind of different than what we were doing. But so this one, it says, write the equation of a parabola given 3 points. Okay, so I start with 3 points that are on my parabola, and I'm trying to actually write the equation for that. So what it says is, what I need to do is I need to write 3 equations by substituting the x and y values into the standard form of the parabola. So I'm gonna start with y equals ax squared plus bx plus c, and then I'm gonna plug in the y and the x into those equations. Okay, so then I'll have 3 equations that are gonna have a, b, and c in them. So then once I have those 3 equations with a, b, and c, we're gonna do what we did in the very last section of chapter 1, and that IXL that you guys all hated. That's what we're gonna be doing. So we're gonna solve it by putting the 2 equations together and the 2 equations together, and then those answers, we put them together and we have to solve out for a, b, and c. And then once we have what our a, b, and c are, we just plug them back into the equation and we're gonna write it out. Okay, so to walk through that with numbers to make it make a little bit more sense. Okay, so first thing, I'm gonna use y equals ax squared plus bx plus c. I'm going to use this equation 3 times, so I'm gonna write it 3 times up here. So I'm using my standard equation. So I have y equals ax squared plus bx plus c. Okay? So now that I have that, each set of points is going into a different equation. So the first one, I have the point -2 and 32. So I can plug the 32 in for my y, and then I can plug the -2 in for both of my x's. So I would have a times -2 squared plus b times -2 plus c. Okay, so I just take that first set of points, I put the 32 in for my y, and then I put the -2 in for my x's in my equation. So now I need to just go ahead and simplify it. So if I take -2 squared, I know that that's going to be +4. So I really have 32 is equal to 4a, and then b times -2 is going to be -2b, and then I have just plus c. Okay, so we have 32 equals 4a minus 2b plus c. So that's my equation that I'm then going to deal with in just a sec. Any questions how I got there? Okay, so let's go ahead, let's do the same thing, but this time we're gonna use the 1 and the 5. So the 5 is my y, so I'm gonna put 5 in here for y, and then I'm gonna put 1 in for my x's. So I have a times 1 squared plus b times 1 plus c. So then 1 squared, I know that that's just gonna be 1, and then 1 times a is just a. So I'd really have 5 is equal to a, b times 1 is just b, so a plus b plus c. So I have 5 equals a plus b plus c. And then my last one, same thing, but I'm just going to use the point 317. So 17 goes in for my y, and then I have a times 3 squared plus b times 3 plus c. So 3 squared is going to be 9. So I'd have 17 equals 9a plus b times 3 is going to give me just 3b. So I have 3b plus c. So far, so good. Yeah. Okay. All right. So now that I have those three equations, we're doing exactly what we practiced in the IXL. We are going to go ahead and put two of them together and put the other two together, and we need to get a variable to drop out. And then once we have those two equations, we have to put those two together and then get another variable to drop out, and then we'll have our equation. Okay, so let's go ahead. We have this first one and this second one. So let's go ahead, let's put this 5 equals a plus b plus c down here. And then we can go ahead and put it over here as well. So I'd have 5 equals a plus b plus c. All right, so I have these two put together. So now it's always going to be easy to get rid of your c because you're never going to have a number attached to it. The only thing is we have positive c for both of them. So we're going to have to make one of the lines negative so that I can get my c to drop out. But I'm not actually going to have to multiply by any number. I would just have to multiply by like -1. So if I do that, I can go ahead and just change all of my signs. So I'd have -5 equals -a, -b, and -c. So then when I add these together, I have 32 minus 5, which is going to give me 27. So I'm going to add these two lines together. 4a plus -a is going to give me positive 3a. -2b minus b gives me -3b. And then c and -c is just going to drop out. Okay, so I ended up with 27 equals 3a minus 3b. All right, so now over here, because I got rid of c over here, I also want to get rid of the c over here. So right now, when I add the c's together, it gives me 2c. So in order to get them to drop out, I need to multiply by -1 or just change all of my signs. So if I change all my signs, I would have -5, -a, -b, and -c. And now I can go ahead and add these two lines together. So 17 plus -5 is going to give me 12. And then 9a plus -a gives me 8a. 3b and -b is going to give me 2b, so I have plus 2b. And then the c and the -c gives me nothing. Okay, so for that equation we came up with 12 equals 8a plus 2b. Okay, so we got rid of all of our c's. So now what I'm trying to do is I'm going to try to get rid of another variable, either a or b, and then we'll solve it out so we'll have one of them, and then we can take that number, plug it back in, solve it to get the second number and then the third number, okay? So if we put these two equations together, so if I bring over this 27 is equal to 3a minus 3b. Well, looking at this, none of these are nicely going to drop out for us, so we're going to have to multiply. So I think it's going to be easier to do the b, but we have a 2 on the b and a -3 on the other b. So what I want to do is I can multiply my top equation by 3, and then multiply my bottom equation by 2. Because if I do that, that's going to then give me a positive 6b, and then a negative 6b, and then the b's are going to drop out for us. Okay, so if I do that, so we're just going to work our way back this way. So if I take 12 times 3, I know that's going to give me 36. So I have 36 is equal to, now I have 8a times 3, so I'm going to have 24a. And then 2b times 3 is going to give me 6b, so plus 6b. Okay, so that's my first equation. When I multiplied it by 3, it turns into the 36 is equal to 24a plus 6b. okay? Then the other one, now I'm gonna multiply by 2. So if I take 27 times 2, that gives me 54. So I have 54 is equal to, and then 3a times 2 gives me 6a. And then negative 3b times 2 gives me negative 6b. Okay, so now that I have it set up so something can drop out, I can just add my equations together. So when I do that, 36 and 54 is going to give me 90. And then the 24 and the 6, so the 24a and the 6a gives me 30a. And then 6b and negative 6b gives me nothing because it's going to drop out. So now to get a all by itself, I can go ahead and divide by 30. So I'd have 90 divided by 30, which I know that's going to give me 3. So I find out my a is 3. Everyone with me so far? Okay. So then once I have that number, I can go ahead and plug it back into one or the other of my equations that just has the a and the b so that we can solve it for b. So let's go ahead, let's put it in. I just have room over here, so let's just do it over here. So I have 27 is equal to 3 times my a, which is 3, minus 3b. Okay, so then 27 is equal to 3 times 3 gives me 9, minus 3b. So I'm trying to get b all by itself, so I can go ahead and subtract over my 9. So I'm going to have 18 is equal to negative 3b. Now if I were to divide by negative 3, I get b is equal to negative 6. Okay, so my b is going to be negative 6 when I solve that one out. All right, and then to get the last one, once you have two variables, so we have our a is 3 and our b is negative 6, we can go ahead and plug into just one of our original equations that we wrote. This one looks pretty easy to me, the 5 equals a plus b plus c. So let's go ahead and just plug into this equation right here. I'm going to erase this side just for some room over here. So if I use this equation, so 5 equals a plus b plus c, so one of the original equations that we wrote, we're just going to put in our a value of 3, so I have 5 is equal to 3. Our b value of negative 6, so minus 6 plus c. Well, I know that 3 minus 6 is going to give me negative 3. So I have 5 equals negative 3 plus 6. Or plus c, sorry, 5 equals negative 3 plus c. Now I can go ahead and add my 3. So I get 8 is equal to c. Okay, so we now solved it for a, b, and c. And then if you look at that slide, it says the last step is once you've solved for all 3 variables, plug them back into our standard form to write our equation. So our equation would be f of x is equal to ax squared plus bx plus c. So now I'm just going to plug in the numbers for the a, b, and c. So I'd have f of x is equal to, my a was 3, so 3x squared. My b is negative 6, so minus 6x. And then my c is 8. Okay, so my equation of a quadratic that's going to go through the 3 points that we were given is 3x squared minus 6x plus 8. Okay? All right, that is everything that I have. I'm going to go ahead and shut my video off, and then if you guys have questions, we can talk about those, okay?